Okay, Year 12, this is the last one for chapter 23, which is D.3, which is on mean and standard deviation of a binomial distribution. Now, we've already talked about standard deviation and variance back in our other topic, in our other stats chapter. But here we delve into it a little bit more, but we relate it to situations where we're talking about probability. So these formulas are a good little reminder up the top here. When we want to work out the mean for the expected outcome for a binomial experiment, that is mu is equal to n times p. Remember, n is the number of trials and p is the probability. We can also express a situation like the scenario like this. X, the random variable or the number of successes that we're talking about, is distributed across this binomial experiment with n trials and p probability, okay, with those parameters. Standard deviation is this one here. Okay, remember this little symbol is a small sigma, whereas this, the total, that's capital sigma. Okay, but this is little sigma over here, which is equal to square root of n times p bracket 1 minus p, and variance, which is related to standard deviation, is sigma squared. And you can obviously see that when you square root both sides, you get the standard deviation that I've highlighted in pink. Now, if you actually have a quick look, let's go to our formula booklet. It is actually in your formula booklet. So on page 5, under 5.8, you can see here we've actually got our formula for the mean, the mean expected outcome. We've got the binomial distribution function actually, which is really good, so you don't even have to remember that, even though you should be very familiar with it from binomial theorem. And variance is here. So they just use the word variance here instead though, rather than writing sigma squared, I suppose. Okay. Which is our symbol for variance, but they've got variance written there, which is actually clearer for you guys. Okay, so don't stress about remembering them. Make sure you know how to use them and what they mean. Okay, and remember, standard deviation is a measure of how spread out all your scores are, okay, in your data. So a bigger standard deviation number means they're more spread out. And smaller obviously means they're more close together. So a simple example might be, let's say we do a class topic test and I've got a range of marks for everybody. If it's very high standard deviation, that means everyone's marks are really spread out. Some people got very high marks, some people in the middle, and some people very low, very spread out. Whereas if your standard deviation is a small number, that means it's not as spread out, it's more clumped together. So it could be that you're all performing very similarly as each other, or it could be, it could reflect something else. Let's say an exam is too hard and everyone does quite poorly, but you're all clumped together. That might actually then give, those hints that, oh, maybe this exam was too easy, or vice versa. It could have been too hard and everyone, sorry, did I say too hard? Too hard, or let's say everyone got super high marks and they're all very clumped together. That might mean the test was too easy, for example. Okay. Now your variance comes in. It's the square of the deviation, or you could say standard deviation is the square root of the variance. Variance is, I guess, a way for us to figure out the standard deviation. And what it is it's the we kind of did this in our last stats topic. It's the average of the square of the differences from the mean. So you look at all the scores, they work out like how far away each score is from the mean. and then it's squared, okay, and then compared. So that is a more effective way of working out, using that to work out standard deviation. Yeah, we could get into that a little bit more another time if you're interested. But yeah, the reason kind of like why they square it is it makes the value actually more, how do I explain this? It sort of makes the number actually more accurate, like, or in a sense, or it makes it more valid. You end up getting a score that represents the spread better, take into consideration that the numbers might be positive or negative. Yeah, so, and squares are easier to work with than, say, absolute value, which also takes a negative into account. But yeah, don't worry about that too much. Let's try the first question. So it says a fair die is rolled 12 times and X is the number of sixes that could result. Find the mean and standard deviation of the X distribution. So, so it looks like we want our random variable is the number of sixes, so that's our success. So I guess not getting a 6 is our failure. So our binomial distribution for our random variable is this binomial distribution where we're doing the trial 12 times and the probability of a success is 1 in 6. Yeah, because it's just a fair die with 6 sides, so getting a 6 is probability is 1 in 6. So that's how we might summarize our information and write it like that. So it says find the mean and the standard deviation. So you've got two parts here. So let's do mean first. So mu equals n times p. So 12 times 1 on 6, very easy. So we get 2. Okay, so 2 is our mean. Okay, standard deviation, sigma equals the square root of, we've got n, so 12 times p is 1 on 6 times 1 minus p. Okay, so you just go to in the calculator and you should get around about 1.29. Okay, so that means we expect in this experiment, when you roll a fair die 12 times, you expect sort of on average to get a 6 2 times, and it's got a spread or a standard deviation of 1.29. So that's the spread of the results that you would get in this experiment. So I should just summarize for you. So therefore, we expect a 6 to be rolled 2 times on average, I guess, with a standard deviation of 1.29. Okay. All right, let's do example 2. 5% of a batch of batteries are defective. A random sample of 80 batteries is taken with replacement. Okay, find the mean and standard deviation of a number of defective batteries in the sample. Okay, so our random variable is a binomial distribution of 80 trials. So you're pulling 80 batteries out, and it says 5% is defective. So 5% is 5 out of 100, or let's simplify it. Let's make it 1 on 20 as a fraction. Okay, that's the probability. And so let's go ahead, do the mean. So mu equals NP. N is 80 times 1 on 20, so our mean is 4. Then standard deviation is sigma equals the square root of 80 times 1 on 20 times 1 minus 1 on 20. So you got to do it on the calculator for me, and we should get approximately 1.95 if I do 3 significant figures, I think. Okay, so that means, okay, so therefore it means we expect to get a defective battery four times, sort of on average, with a standard deviation of 1.949. So we expect to get a defective battery on average 4 times, but overall, sort of the spread of all the different results that you could get is 1.949, like standard deviations away from the average. Okay, so please have a go at the questions, year 12. It is exercise 23D.3. It is on page 625 in your textbook. Please have a go, mark your work as well, and let me know if you have any questions or issues when I see you at school.